Hello student, today we are going to revise chapter 2 motion in one dimension, class 9. Class 9, chapter 2. Motion in one dimension. First of all, we know about a scalar and vector quantity. Vector quantity, a scalar and vector quantity. A scalar quantity is that quantity in which it has only magnitude, not direction. Have only magnitude. Vector quantity have direction as well as magnitude. Direction and magnitude. Distance is a scalar quantity because distance have no direction, it have only magnitude. But displacement is a vector quantity because it have magnitude as well as direction. Clear? Next topic is distance and displacement. Distance is a path which is traveled by a body. Means actual path traveled by your body, covered by your body is known as distance. Clear? But displacement is the shortest path traveled by your body from initial to final position. Suppose a body is start from this point A and go to this point B. Then the actual path is whole distance, whole path. This is the actual path. This path is known as distance covered by your body. Actual path covered by body is known as distance. But this one is the initial position and this one is the final position. The shortest distance between the initial to the final point is known as displacement. Shortest path is a straight line path from initial to the final position. This path is known as displacement. Why? It is the shortest path. There is no any other option, other path which is shorter than this straight line path. So this straight line path is a displacement and this long path is known as distance. Clear? Distance has no direction because it has lot number of more number of direction Here the direction of the body in this direction, here the direction of the body in this direction, here the direction of the body in this direction, in this direction. Lot of direction in distance. So we cannot recognize which is the main direction of the body when travel on a curved path over a long distance. But in this straight line path, we have a definite path, definite direction, which is in this direction from A to B. It have only one direction, so it have a direction as well as this magnitude. So displacement is a vector quantity, but the distance is a scalar quantity because it have infinite number of direction. There is no any definite or fixed direction. Okay. Our next topic is speed and velocity. Speed. The distance traveled by a body per unit time is known as speed. It is a scalar quantity because distance is also a scalar quantity. But velocity is the displacement, not distance. Displacement traveled by a body per unit time or covered by a body per unit time is known as displacement velocity. And velocity is a vector quantity because due to the displacement, and displacement is a vector quantity. That's why the velocity is also a vector quantity. Clear? Acceleration is also the rate of change in velocity per unit time. Means change in velocity per unit time is known as acceleration. Acceleration is also a vector quantity because it is a velocity per unit time. Due to velocity, acceleration is also vector quantity, and the unit of speed and velocity is meter per second, but the unit of acceleration is change in velocity by time. That is unit of velocity is meter per second and the time is second. Therefore, meter per second square. Clear? Okay. Next topic is chapter 3rd, that is laws of motion. Laws of motion. First law of motion. First of all, you know about inertia. Inertia is the characteristics of a matter. There are a lot of characteristics of a matter. Lot of characteristics. It apply force. It have a momentum. It have a mass. Lot of characteristics. It create a current, magnetic effect, lot of characteristics. Therefore, inertia is the characteristics of a matter, one of the characteristics of a matter, or we can also say that property of a matter. So what is its use? It resists the change in it. Means inertia does not want to any change in the matter. What is its mean? Change mean it have three characteristics, three conditions. One is motion, rest, and in a particular direction. Three changes. Means inertia does not want a body. If a body is in rest, it does not want to change in its initial position. If the body is in motion, inertia does not want to change its condition, that it does not want to comes the body in rest. If the body is in particular direction, inertia does not want to change the direction of a body. Means inertia is the characteristics which does not want to change any change in the matter, in the condition of the body. Condition of the body is rest, body in motion, body in particular direction. It is a property. Clear? Inertia depend upon the mass, directly proportional to the mass. If the mass of the body is maximum, the inertia of the body means the resisting property of the body is also a maximum. It does not want to change in its initial position. If the mass is low, means minimum, the inertia is also minimum. For example, a car and we take also a truck. One is car, other is truck, heavy vehicle. If both are in motion, then it is very difficult to stop the truck as compared to the car, because truck have more inertia, because it have maximum amount of mass. It resists to change in its motion. It does not want to change its motion. But in car, the mass as compared to the truck, the mass of a car is minimum as compared to the truck. That is why the car is easily stopped by applying brake as compared to the truck, because it has a less inertia, less due to the less mass. Is it clear? The Newton's first law is fully depend upon the inertia. Newton's first law said that if a body is in rest, a body is in motion, a body is in a particular direction, it does not want to change in its state. It always remain in its state until an external force applied on a body. Means if you not apply a force on a body, then the body remain in its initial condition. Means a body is in rest, remain its rest. A body is in motion, remain its motion. It does not stop until an external force is applied. If a body is in motion, when we apply force to stop, then it can stop. If a body is in rest, we can apply force, then it can move or try to move. or if a body in a particular direction, if you not apply a force, then it cannot change the direction. But we can say that when we roll a ball on a ground, then why it is stopped? When we roll on a ball on a ground, it stops because due to application of force. And that force is frictional force applied by the surface of the ball and the surface of the ground. And that frictional force stops the motion of a ball. So a ball is stopped when we roll on the ground. If the frictional force is not present on the ground, then it cannot stop, it moves infinitely. Newton's first law gives the definition of force and also gives the characteristics of inertia, define the inertia. Means what is force? Force is an agent or something which change or try to change the condition of the motion of the body. Means change or try to change the rest of the body, motion of the body or direction of the body. Clear? Our next law is second law, motion. Second law states that the rate in change in momentum per unit time is known as second law of motion. Is directly proportional to the application of force. Not second, sorry. Second law of motion states that the rate in change in momentum per unit time is directly proportional to the force. It means that if we apply force on a body is maximum, or if the rate of change in momentum of the body is maximum, it means that the force is also a maximum applied. If the force is applied on a body is minimum, it means that the rate in change in momentum is also minimum. Change in momentum means it must apply force on a body. If there is any change in momentum of a body, change in momentum in a body, it means that force must apply on a body. If there is no any change in momentum, there is no any application of a force on a body. How much force applied on a body? Change in momentum defines, say that the force is applied on a body, but how much? The force applied on a body means the change in momentum per unit time gives the magnitude of force, application on a body. Clear? Okay. Third law states that which gives second law gives the magnitude of the force, gives the formula to calculate the application of force, calculate the amount of force applied on the body. But third law gives the behavior of the force. Third law states that to every action is and reaction always opposite to each other and equal to each other and apply different on a different body. To every action and reaction one minute. To every action there is always equal and opposite reaction. Means when you apply force on a body, means applied force is known as action. Then the body also apply force on a first body, which applied by reaction. Then the second force applied by a body is known as reaction, which is equal to the first body. And both action and reaction applied on a different body, not on a same body. Clear? That this is the second and third law of motion. Okay, thank you. Next topic we will study in next video.